students, welcome to mathgotserved.com. In this clip we're going to be taking a look at a problem that we're going to be solving by applying the properties of triangles and parallelograms. Question reads, quadrilateral EBCF and segment AD are drawn below such that ABCD is a parallelogram. Segment EB is congruent to FB and segment EF is perpendicular to segment FH. If the measure of angle E is 62 degrees and the measure of angle C is 51 degrees, what is the measure of angle FHB? Alright, so let's go ahead and populate the diagram with the information that we are given. Alright, so first of all, we're told that ABCD is a parallelogram. Okay, so this quadrilateral right here, this is a parallelogram. So what do we know about that? Well, that means that opposite sides are parallel, right? So if it's a parallelogram, this side right here is parallel to this side, okay? And this side right here is parallel to this side right here. Bam, bam. Okay, moving along. EB is congruent to FB, so EB, this side right here, is congruent to FB, this side right here, in this triangle EBF. And then EF is perpendicular to FH, which basically means that these two sides have a 90-degree separation. All right, let's go ahead and mark that. So we have a 90-degree separation here. Bam. Okay. What else? Measure of angle E is 62 degrees. So this angle in the lower left corner, that's 62 degrees. And then the measure of angle C is 51 degrees. So this angle up here is 51 degrees. And we're to find the measure of angle FHB. So this is the problem. This is what we need to find. Question mark. What is that? We don't know. Okay. All right. So before we get started, we're going to go ahead and review three important pieces of information. One applies to triangles and the other two apply to parallelograms. So what we're going to do is we're going to go to our website, mathgotserved.com, and then we're going to go to geometry. We can either click here or click on here. Alright, so this is our geometry site. So if we scroll down, let's go first of all go to the theorems and postulates, okay? We're going to look at number 7 on the triangles, the isosceles triangle theorem. So if we click on that, it reveals a very important piece of information. It says that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. Alright, so if AB is congruent to BC, then the angles opposite those two sides, angle A and angle C, are also congruent. Very important. Keep that in mind. And then if we go to our vocab section and go to parallelograms, alright, we all know what parallelograms are, right? Quadrilateral where opposite sides are parallel, they're also congruent. Let's note properties 2 and 3. Property 2 states that opposite angles are congruent. So angles opposite each other are the same. Measure. And then number 3, adjacent angles are supplementary. Adjacent means next to each other. Okay, like angle A and B, C and D, A and D, or B and C. Supplementary means adds up to what? 180 degrees. Alright, so let's keep those three pieces of information in mind. Alright, if two sides of a triangle are congruent, the angles opposite those sides are congruent. And then for a parallelogram, opposite angles are congruent and adjacent angles are supplementary. Alright, let's get started. So first things first, let's focus our attention just on triangle BEF, this triangle right here. Okay, we're told that two sides are congruent in this triangle. So what piece of information that we reviewed can we use here? We can use the isosceles triangles theorem to come up with a conclusion. Okay, so since BE is congruent to BF, right? Then what can we conclude? Then the angles opposite those sides are congruent, right? Then the measure, or we can just say let's see, angle BFE, angle BFE, this angle right here is congruent to angle E. Bam, bam. All right, we know that because of the isosceles triangle theorem. All right, so it follows that the measure of angle BFE is equal to the measure of angle E. We know what the measure of angle E is, right? The measure of angle E is 62 degrees. So since BFE and E are the same, the measure of angle BFE is 62 degrees also. Nice. So right here, this angle right here is 62 degrees. Now let's stay with that triangle. Let's see if we can figure out what the measure of this angle up here is. Okay, measure of angle EBF. What is this measure right here? Let's see if we can figure that out. So first things first, let's set up an equation. We have a triangle. We know two base angles, so we can find the third angle, right? So we can state that the measure of angle EBF, so this top one right here, plus the measure of angle E, so measure of this one and this one, plus the measure of the one we just found, measure of angle BFE, guess what? It's all equal to 180 degrees, right? Using the triangle angle sum theorem, by the triangle angle sum theorem, which basically tells us that the sum of angles in a triangle is 180 degrees. Neat. Okay, so if we know that, let's populate the measures. Measure of angle EBF, we don't know, that's what we're looking for. Plus the measure of angle E is 62, and the measure of angle BFE that we found is also 62. Okay, all that together is 180. So it's gonna be algebra here. Assume this is an algebraic equation where measure of angle BEF is your unknown. That's your variable. Okay. All right, so that's what we're gonna solve for. So we're gonna combine these two numbers. Measure of angle EBF. If you add these two, is 124 is equal to 180. And then to get measure of angle EBF on its own, you subtract 124 from both sides, and that yields the measure of angle EBF is 180 minus 124, 10, 6, 7, 2, 56 degrees. Bam. All right, so this angle right here is 56 degrees. Now we're done with this triangle. We'll come back to it later, because this is going to be it's going to be instrumental in the future. All right, so let's just ignore that for now. Now let's shift our attention to this cluster of angles here. This one, these two angles right here, these two angles. Let's take a look at them. All right, so what we're going to do is we're going to create a statement using the angle addition postulate. All right, we want to determine what this angle is, what that angle measure is. Okay, so using the angle addition postulate, we can say that the measure of angle BFH, this tiny little angle right here, plus the measure of angle BFE, the blue angle over here. Okay, so the blue plus the green is going to be the combined combination of both of them, which is the measure of angle EFH. This is the angle addition postulate. Okay? All right, angle addition postulate. We know two of these measures, so we can find the third one, right? So since we're told that segment EF is perpendicular to segment FH, that automatically follows that this angle EFH is what? Is 90 degrees. So that follows that the measure of angle EFH is 90 degrees. Okay? We're also told that measure of angle, well, no, we're not told, we found it out. BFE is 62 degrees, right? So let's set up an equation. So measure of angle BFH, what we're looking for, plus the measure of angle BFE, which is 62. If we combine those together, we're going to get EFH, which is 90 degrees. Bam. So we have another algebraic equation. We're going to solve that for measure of angle BFH. Just subtract 62 from both sides. So subtract 62 degrees from both sides. And then you get the measure of angle BFH is 90 minus 62 is 28 degrees. Alrighty. So this angle right here is 28 degrees. All right, moving right along, you notice we're kind of gradually working our way to this triangle right here. We already have one piece, okay? Now this is the goal. If we can figure out what this angle is right here, then we can use the triangle angle sum theorem to knock out the problem, all right? So what is this angle right here? This angle FBH, what is that? Now we're going to switch to the properties of parallelograms, okay? Now if you take a look at this angle right here, this angle right here and this one, these two are what? They are consecutive angles of a parallelogram. And what did we say about consecutive angles of a parallelogram? We said that consecutive angles of a parallelogram are supplementary, or they add up to 180 degrees, right? All right, so let's go ahead and write down an equation using that piece of information. So the measure of angle B, right, plus the measure of angle C is what? Is 180 degrees. How do we know that? It's because they are consecutive angles of a parallelogram. That's one of the properties of parallelograms, okay? Consecutive angles of a parallelogram. Bam. Consecutive angles of a parallelogram are supplementary, or they add up to 180, okay? Angle C is 51 degrees. We're given that, right? So the measure of angle B plus 51 degrees is equal to 180 by substitution. So you subtract 51 from both sides of the equation. It's like an algebraic step, okay? We want to isolate the measure of angle B. So the measure of angle B is 180 minus 51, which is 129 degrees. How does that help us? Well, we're going to use the angle addition postulate again. We know the entire angle is 129, right? So if the entire angle is 129 and we know one part of it, we can use the angle addition postulate to figure out the other part. Okay? So let's go ahead and write down a remark. to focus our problem solving process, which is that the measure of angle FBH, right, plus the measure of angle, so this part right here, this piece, that's FBH, plus the measure of angle EBF, the other one, together they form the measure of angle B. Bam. How do we know this equation is true? Angle addition postulate again, like we used before. So based on the angle addition postulate, okay, so nice. So if you add this one and this one, you get the whole thing. That's what the angle addition postulate is. What we're looking for is the measure of angle FBH. So measure of angle FBH plus the measure of angle EBF. EBF is what? We already know what it is, 56, right? Bam, 56 is equal to measure of angle B, which we found to be 129 previously. Right here. See right here? Okay. Now, to get FBH by itself, we just simply subtract 56 from both sides of the equation. And then we're going to get the measure of angle FBH is equal to, subtract these two, 73 degrees. Bam. Okay. Almost there. So this is 73 degrees. So to wrap things up, we're going to use the triangle angle sum theorem, right? So what does that tell us? It tells us the sum of angles in a triangle is 180 degrees. Let's go ahead and write that down. So the measure of what we're looking for, angle FBH, the first angle in the triangle plus the second one, measure of angle, no, we're looking for FHB, right? So let's write that first. Doesn't really matter, but I want to keep what we're looking for on the left side. So measure of angle FHB plus measure of angle FBH, right? The second angle in the triangle plus the third one, measure of angle HBF or BFH. Let's call it BFH because that's the notation we used earlier right here. So measure of angle BFH it's all equal to 180. Right? How do we know that? It's the triangle angle sum theorem. Triangle angle sum theorem, which tells us that the sum of angles in a triangle is 180. Okay? So let's substitute. So what we're looking for, the measure of angle FHB plus the measure of angle FBH. We know what that is, 73. We just found it. Plus measure of angle BFH. BFH is 28. So one thing you can do is you can either just look up to what we found or look at the angles that we populated in our diagram, right? So that's quicker, so you don't get confused in your work. Is equal to 180 degrees. Okay, so let's go ahead. This is an algebraic equation. We just want to get measure of angle FBH on it by itself, and we are done. So combine like terms, measure of angle FHB plus add these two together, 101 is equal to 180 degrees. And then final step, subtract 101 from both sides. When you do a subtraction, you're going to get the measure of angle FHB is equal to 79 degrees. Bam. All right, there goes your final answer. Option number 1 is the correct answer to this question. Okay. Thanks so much for taking the time to watch this presentation. Really appreciate it. Thanks to all of you who've been supporting our videos with your likes and comments and subscriptions. Keep it up. If you have any questions about this problem or any geometry questions in general, specify in the comment section below. We'll be more than glad to support you. Thanks again for watching. We will see you in the next video. Goodbye.